this video, we're going to look at the parallel line theorems. So the first one we're going to look at is called the opposite angle theorem, and that occurs when we have two lines that are intersecting. I'm going to draw in a straight line here, and then I'm just going to draw in a second one that intersects it. So when you have two lines that intersect, the angles that are formed that are opposite each other are called opposite angles. So for example, this angle at the top is opposite to the angle that's at the bottom. So these two angles, according to our opposite angle theorem, are equal to each other. Also, because I have two intersecting lines, there are angles here. I'll call this one x, and I'll call this one y. And these angles that are opposite to each other are also equal. So in our intersecting lines, we end up with two pairs of opposite angles that are equal. So the next thing we're going to look at is what are called our parallel line theorems. So in order to do that, we'll need two parallel lines. So I'm going to draw one line here, and then one below it that is parallel to it. So I'm going to indicate that they're parallel because I'm going to put two arrows that are matching to say that these are two parallel lines. And in order to create our parallel line theorems, we're going to use what's called the transversal, which is just a line that's intersecting two or more lines. And I'm going to draw one right through here like this. So this line here, this is called our transversal. So now I'm going to just label some of the angles that we have created by having two parallel lines and a transversal. So I'm going to call this angle A. I'm going to call this angle B. This one's going to be C. This angle here, this is going to be D. So there's four angles at the top intersection. And I'm going to put another one here. I'm going to call this angle E, F, G, and H. So there's four lines that are also created by the intersection at the bottom. So the first set of angles that are created in our parallel lines are what are called alternate angles. And you can tell they're alternate angles because they create what looks like a Z. And we use them as, and we call it a Z pattern. So if you can look, this parallel line, if I go like this, and then come down, and then come across, this creates what looks like a Z, right? And then inside our Z, so here, in the little nooks, this angle and this angle, according to our alternate angle theorems, are equal to each other. So, looking at our Z pattern, I can see that angle C is equal to angle F. Right? So, if I look at my parallel lines and my transversal, I can also see that I can create a different Z, and I can draw one backwards. So I'm going to draw another one that goes this way. And it's not really a Z, it's a backward Z. But if I look at this one, inside my Z are two more angles, and it tells me that angle D is also equal to angle E. Right? So these are our two Z's that we've created. In each pair of parallel lines with a transversal, you're going to find two sets of Z's or two sets of alternate angles. So I'm going to put a 2 here. There's two of these in every set of parallel lines. The next one we're going to look at is the corresponding angles, and they create an F pattern. So if I wanted to create an F, the one that I can see most clearly is going to be here. If I drew a line, and one line here and one line here. So to create corresponding angles are the ones that are under the forks of the F. So there's one here, and there's one here. So according to my F pattern, angle D is equal to angle H. F's are a little more complicated because I can draw an F that looks like a regular F, but I can also draw a backwards F, so one that goes this way, with one fork here and then one fork here. So that would tell me that angle C is equal to angle G. But I can also draw what look like upside down F's. So there's one that goes this way and like this. And we said it was the parts that were under the forks. Because my F is upside down, I'm actually looking at the ones on the top, and that will tell me that angle A is equal to angle E. Right? And then similarly again, I can draw an upside down F but backwards, so that will go this way, right here. And this last one tells us that angle B is equal to angle F. So looking at this, that means that we actually have 4 sets of F's in a grouping. Right? So the last one's a little bit different. These are not equal angles, but in co-interior angles, so what creates a C? So if you'll see, we can have one C that goes this way, and then one backward C that goes this way. The C pattern, or co-interior angles, they don't tell me that the angles are equal, but instead that they add up to 180 degrees. So if I look at my regular C, it tells me that angle D plus angle F is equal to 180 degrees. And similarly, we said if we drew a backward C, that means that angle C plus angle E will also add to 180 degrees. So in each of our parallel lines, we can create 2 of these C patterns.